Okay, hello everyone. We are back to doing a design review for our new tabular functionality for Wolfram language. So today we get to talk about, it seems, missing and anomalous data. So who's
Yes,
starting
we,
here?
I'm going to present this part. We haven't cycled back to this in a while. We thought it was time to do some updates, ideas,
So by the way, in
design
terms of
choices.
formatting, obviously issing is not a great, there's a bit of an issue with issing. Presumably we're
No,
going to format missing in some graphical way.
it should be like a dash that what you see in the first column. This is what we decided for dataset, and unless
Yeah,
we
I
have a
know.
better proposal.
I would like to, we don't have anybody from design here, I don't expect. I would
I
like
don't
to
think so.
suggest, if it is possible to do it, that we go for something which is more sort of a little bit more graphical, like a slightly a dash like that, but thicken it up uh and make it gray. See what I'm saying?
It should be, if you do dataset of that, if you evaluate the tabular and you do dataset of a tabular, it should be gray, as I remember.
Do I want to initialize set the initialization?
Yeah, yes for later. Uh, yeah.
Okay,
So
that helps. That's much better.
yeah,
That's just fine.
I think we can use this
That's
as a.
fine. Yeah, we
If
can use
okay,
that. Just get it right. I mean,
yeah, yeah.
okay.
Okay, so I put the documentation in CVS for transform missing, which is derived from transform columns and such. You can click on that link if you have it.
I have no idea.
To
When did
directly.
you did? When do I have to update?
Is it from today or late yesterday?
I haven't a clue. I don't
Okay,
know.
okay, fine. But yeah, we can also just look at the examples here. The notebook, they convey the basic of the syntax.
Um, okay. Uh, well, where is it?
Yeah, yeah. I don't know why it wasn't picked up today. It should be in the prototype build. I will check tomorrow. It's probably picked up.
Well, I see that the
Um,
documentation just updated, so I don't know why that was, but it seems to be updated now.
yeah. Yeah. Okay. So our proposal for this is something much simpler than what we had before. So now that
Is
we have
this the
design,
proposal or is this not the proposal?
no, this is the proposal. This is the proposal with the syntax that we have here. Is the
You know,
proposal.
I just want to say that in these things here, I really don't like seeing literal data. I think it's a mistake.
Well, the image is one of many. I think Roger is working with Tim on a
Okay, but
unified
I think we
design
should be,
language for
I
this.
think we should, Roger, I think we should never have explicit numbers here. This is not an example. We should have
Yeah,
something where it's sort of grayed out. It can look
yeah,
vaguely
yeah,
like
yeah, yeah.
numbers, but
I completely agree with you. It's an illustration. It's not.
yeah, right,
Yeah, yeah.
Well,
right.
but what how I mean, especially when you're talking about missing, right? It's sort of important to say like this is actual data versus this is
Oh, no, no,
missing
I know,
data. Like
but
how do
you
you
can,
show it?
but I think it will be possible to show it. We need a design language where it's kind of like there's squiggles there that are obviously meant to be numbers, but they're not actually showing numbers, if you get what I'm saying. I think we can come up with something. This is not, we've done this, but in the past, we've literally in more diagram and more drawing type things, we've just done literally a squiggle, a wiggle, wiggle, wiggle type thing.
Right, but the point is, what I would worry about is that we use some notation like a squiggle or like some hash signs or something like that to
Now,
be like
hash
this is a
signs won't
number.
work.
Right, but,
Hash
but
signs
then
won't
it's going to
work.
be you're going to have to know a fair amount to know that the dashes are the missings and not the squiggles. But whatever.
Let's see what we can do, and let's not get. But I take your point, but let's see what we can come up with.
Okay, so basically the concept behind this that we try to simplify a lot is that instead of defining a new transformation language, we already have transform columns plus addition like whole tabula, column wise and such, reduce tabula, which is the other way around. So this was kind of a weird mix of both. So our proposal here is like, let's simplify this to the most common cases and just have a more complicated cases that will also be interested into less, like a fewer amount of user, smaller amount of user, fewer users, to be implemented using transform columns and missing fallback, because it's going to be very difficult to cover all those specific cases. And we can have a very tight list of things that are the things that 90% of the time you're going to
By the small point here,
on this.
By the time you say forward and then use the next, this obviously should say next element.
Yeah, this is implemented as next and previous. I have those as synonyms. You can both use forward and backward and next and previous.
Okay,
so if you prefer next and previous, okay, and then I go with next and previous. And
okay, all right. But anyway, explain how this works.
Okay, so this basically, the syntax is quite simple. So you have the examples here in the notebook, whatever. Like you can scroll down and you see all of them. So mean will basically, if you don't specify any column, it will apply this to all the columns. And we have only few of them. We have mean, median, and mode. And those cover the vast majority of cases about what you do with statistical functions. Again, if you want some weird statistical thing or special case, you can do transform column with missing fallback, and then you can put whatever function you want. And I think that's preferable to having
here, for example, the syntax would be column name arrow mean would mean transform the missings in that column. Is that correct?
Exactly. If you only want to do column A, you do A goes to mean.
And what does mean mean?
It applies the function mean to the column.
So it replaces all the missings with the mean of the whole.
Yep.
Exactly.
The whole column.
It's a basically very simple constant replacement, and then you can use constant to escape whatever, like constant 0 in this case, or constant -1, or whatever special value you want.
It might be nice to just allow the possibility of just saying 0.
I know I had that, and then I added strings, and then I added other things, and then people came to me saying the design was mad. So this is kind of a very conservative design. I think we can start from here and re-add some sugar, being very conservative. But let's say I just want to present you, the tighter possible design.
Yeah, but this is bizarre.
This is actually no. You can just say random, and I have an example. These are just, and that will randomly sample from the column, and I have an example here. Or
that's
you can
randomly
put a
from the existing distributions, but that's not. Look, I think that should be random element. If you're picking up another element at random, is that what you're doing?
Yes. Yes.
Okay, so I mean that's random element, and that's
okay.
And then we have something more like random distribution or something. And then what we want to do there is random distribution.
It's not random distribution though.
It's random sample from random variate
distribution.
From the distribution.
Yeah.
Okay, sorry.
Random variate.
What we want to say is random variate. Yeah. Okay, but then I don't understand why. I mean, what I would like to see there is just literally, don't invent a new language, just have random variate of normal distribution, whatever it is.
It's not. It's
0, 4 or
it's
something.
not really a new language, because you put a distribution there with I just put the most exotic example in here. But if you go to the scope in transform missing, of course you can put normal distribution 0, 4. Yeah, sorry, go.
The problem with just saying random variate of distribution, it means that it's gonna kind of evaluate and gives you
Of course.
But we don't know how many you need a priori, right? In a way.
Yeah, of course. So the only way we can do this is if we can somehow find an excuse to put it on the right-hand side of a delayed rule.
Yeah.
Exactly. Which was a previous design with arbitrary function that was kind of getting out of control in terms of semantic of you do it for one column, for the whole tabular, how do you pass the whole tabular in, stuff like that. So again, the design principle here is simplicity. So if you do put normal distribution 0, 4, it's just going to sample from that. If you do put normal distribution with symbols, this is documented syntax in estimated distribution. So it's just going to call estimated distribution on the column on the fly. And I think this is a kind of easy sugar.
No, I think it's completely crazy to have names there which are not scoped.
But
What the
in
heck,
estimated distribution I'm following estimated distribution.
I
It's
know,
got
but it
scope
has
there
scoping.
as well.
It has scoping because
No,
it says.
no,
Well, it should
no,
have
no, no.
scoping.
Open it. I was also surprised. It's not like ND-sol.
Roger, can you comment on that, or somebody else, please?
Yeah, random variate, the sort of estimated distribution.
Estimated distribution. We're talking
Because
about.
you can pass parameters that are numbers.
You
know,
can,
so
you can. There is a version of it where there is scoping added. If you give initial values, let's say for all of the parameters, PQ, etc., then it's more along the lines of scoping, but you don't need it.
That's weird.
I also like, and can you do things like estimated distribution of normal distribution, mu, comma 2 mu?
Yes.
Yes.
You can?
Yes.
And just like that, and then you don't have to say mu somewhere else.
Yes.
Weird. I also think it's weird.
But
what's
it's fast.
an analogous function?
Fast to
Hold on.
type.
What's an analogous function? This because what this is doing is it never has to tell you the values of alpha and beta, right?
No, it returns the symbol with the values instantiated. There is a sister function, which is find distribution, whatever
parameters. But the similar thing to this, it's for example, distribution fit test, where you're gonna fit to to the distribution, but unless you ask for a full test conclusion, you will not know what the estimated distribution is, and you can have rejected, not rejected. Can you fit a normal distribution to your data? And so this kind of way.
What this is analogous to is estimated function, which is a function we don't have, right? Because what we have is find fit. See what I'm saying?
Mm-hmm.
Which has
but I mean, there's a concept that we're missing, which is sort of model structures, and a distribution is kind of like a model structure. It's a family of distribution if you think of all the possible parameter values.
Yeah. Okay, but look. One of the things that's driven me crazy is that find fit returns, you have to substitute in values and things.
Right.
It isn't doing the thing that this does,
right,
which is to produce, what instead it should do is if I say find this fit and I give it a general form of the fit, like I say sine, A sine BX or something.
Well, I think there are use cases for both, and I didn't really want to find, distribution parameters, but there was a lot of argument within the team, so we decided to provide it.
Okay, but look. The thing that we're useful here, and I've needed a million times, is just fill those freaking parameters in to this function here.
We did something like that with fit that allowed you to get different things out using, I think, a rule syntax. I can't remember exactly what it looked like.
But this is crazy that we have distribution, estimated distribution, and what we want here is just this. That's what you want most of the time. I mean, you also sometimes want the parameter values, but much of the time you just want this.
Well, that's why we built estimated distribution, for workflow reasons.
No, I understand, but I'm saying we need an estimated function as well. Right?
What if you okay, crazy idea. What if you just drop the
parameters?
Oh no, this is more general. Yeah, I was thinking if you just drop the parameters. But then we need a clear definition of what is a parameter,
well,
and what is a symbol with no value, basically.
No. But if what this was something like this.
Distributions have only pars. This has both pars and vars. That's the problem.
I understand, but let's say you give the var here.
Yeah. Exactly. So the problem here is that the distribution are a fixed list, while here you could have sin, or you could have an arbitrary other thing which is not sin. Yeah, it's not a fixed list. It's an arbitrary list.
I don't understand what you're saying.
Like in estimated distribution, you have like normal distribution. Normal distribution is from a fixed list of distribution functions.
Matter. That doesn't matter. I mean, all we say here is we can make the assumption that every every undetermined symbol is a thing you have to try to fill in.
This is what I said. We have to agree on a clear definition that a symbol with no values attached is a free symbol.
Right. Well, if it
Well,
isn't
it
a
has
parameter,
to. Well, it has to because otherwise it won't. You won't get a number, and you won't be able to fit the data.
Yeah,
yeah, right.
exactly.
Well,
Yeah,
I mean,
I think this is neat. It's short. It doesn't require you to give you any property.
right. I mean, I don't like the fact that there are these, this should be added to our discussion about variables, because this is another case of variables.
Mm-hmm.
See what I'm saying?
Yeah.
Where these things are really formal variables whose names are utterly irrelevant.
Exactly. They could be whatever. Yeah.
They're a bit like pattern variables.
Yes.
And, there's a certain argument that really the way this should work is with pattern variables, because if we have pattern variables, I mean, if what we had here was blank sign blank X, that would be semantically reasonable.
Well, except you have to be able to return what the blank, like above it. Oh, I guess if you're
No,
doing
this is a
not
syntax
in
with
this
no
case.
parameters.
I mean,
yeah,
if
exactly.
this is basically estimated function, and it's just blanks, that is semantically exactly right, I claim.
Well, one weird thing would be if you use right. If suppose inside of the body of your estimated function you call it, match Q or something, and there's a blank on the right hand side.
Right. So Stephen, we already
And it's
had a
ambiguous.
discussion about this in LCC, and we decided to add a string argument to find fit, which was like best fit and function to return it as a pure function. And it's basically waiting on Rob to have enough free time from Tabular to actually implement these things.
Oh, so we solved this.
Yes.
Okay. Although the way estimated distribution solves it is different, and I think we need to bring those together. But that solution for find fit is certainly a good stopgap. Rob, can you speak to that? Rob?
If you're
here?
speaking, you're muted.
Yeah, I forgot I muted. Yeah, it's I think it's a reasonable solution. It'll just take a bit of a block of time to actually do it.
It'd be nice to get it done. Is there anybody it can be delegated to? Well, it'd be nice if you could delegate. Okay, whatever. Let's get it done.
Yeah.
I mean, but I'm telling you, I don't like the design inconsistency between estimated distribution and the lack of an estimated function and the way find fit works. I mean, I would say
This is how we make progress.
Whatever. I mean, I think that the correct way forward is find fit with this additional argument that gives the functionality, and then let's do another design pass on estimated function, estimated distribution. Does that make sense? And I favor using pattern variables, or at least allowing pattern
We
variables.
should fold the discussion about nonlinear model fit with Tabular in that, because we need to talk about model language for that.
Yes,
as
that's
well.
fine. But I'm just
Right.
putting it out there that I think estimated function with blanks here will be very useful.
Okay.
And is semantically reasonable. I mean, it's the thing, one needs endless time just to get a workflow clear. You've got some data and you want to plot it together with its fitted distribution, right? You want to plot it together with its fit. And if we could say plot data, okay, I'm prepared to allow myself an evaluate here, although I don't like it. Oh no, we can't do that. We have to say list plot the data, right? We'd be saying list plot show list plot of the data together with plot of estimated function data, comma, blank sign blank times x.
I don't understand what blank sign is doing there.
That's where the parameters are.
That's
Those
what the parameters.
What?
That's the parameters.
But isn't blank sign something that has a head?
No,
no,
there's a
there's
space there.
No,
That's
there's a
blank
space.
time sign.
Oh,
But,
my
but the
God.
space admittedly is pretty darn obscure.
Yeah.
Oh, no.
Okay. So I mean, you can name it if you want to. It doesn't make any difference. You can call it, A blank if you want to, A blank or B blank if you want to.
Overall, I feel like this design is, kind of nice, except completely different from the way every other function currently works.
Yeah, exactly. We generally scope things that are variables.
Yes,
And write them as
this
symbols,
is a case where
not as blanks.
I understand. I mean, and I think
Yeah,
there may be cases in
we
neural nets
scope
where
them
this is
in
happening
in a
as well.
weird way, though. Yeah, because like stuff like solve doesn't really scope them if they're already defined.
But remember,
scopes
solve
them
doesn't have this
later on.
parameter issue. Reduce has something of the parameter issue, but only just. This is the case. These are parameters that don't matter.
Why are you drawing a distinction between solve and reduce?
Well, it's not a very real distinction. I mean, because there are extra parameters in reduce.
There can also be extra parameters in solve.
Fine. But the whole point here is that you are taking those blanks and instantiating them. That's
this is maybe closer to minimize, actually. Right, because minimize minimize returns two things. It returns the evaluated, objective
right, but it doesn't
function.
return a functional form. This is something that returns a functional form. That's the difference.
Yeah.
We don't have very many things that do that. I mean,
well, what minimize? I mean, it semantically does return that, right? The first argument is the objective function with the parameters plugged in.
Correct.
It's just that it might be an unevaluated symbolic expression that you need to call replace solve to actually evaluate.
Well, does it? Okay, can minimize? Yeah, minimize can return a symbolic form for the first argument.
Yes, I mean that can be parameters in minimize. The symbolic minimize function can deal with parameters.
But the point being, in the first argument of it, it plugs the parameters in, which is the distinction we were making earlier about
it plugs the variables.
The variables.
You minimize with respect to variables. There might be additional quotes variables, which we usually call parameters. In which case, what comes out is a function of those parameters.
Explicit function of those parameters, whereas here it is not. It's only a function of the variables.
Right.
Exactly.
Yeah, because we minimize away the parameters.
Yeah. So, I mean, I really do think this is a somewhat different case. Go ahead.
Well, no, I mean, the distinction you were making earlier was that this is different from some other functions like, solve or something, in that we're going to automatically plug in. You never need to see what alpha and beta are. They're just going to get plugged into the function.
Yes, and
right?
I claim this is unique in that respect.
My point is that minimize does exactly that.
Okay,
right?
let me understand that. Give me an example. Is it a parametric minimize of some kind?
No, just normal minimize. Like, look at that first example, but then maybe give it one other parameter. Like, say that, the first input, make the objective function times y or something.
Actually, why isn't what you want a find fit value? Which just like, right, we have solve and solve values. Solve returns rules, solve values returns, the values plugged in.
Do we have a minimize values actually?
No, we have argmin and we do have
argmin
actually
is the opposite.
Min value.
Okay.
Min value and argmin. They give, the first or the second. And those are very useful for workflow reasons. But we added them many years after we had this first one.
Right.
Yes.
Right.
But what's the analogy here?
Because just like in the case, with the underscores, right? On the min value is just, you never actually see X. X is just injected in.
I see. But
right, just like we have desolve and desolve value, right? Desolve
and actually to fill in a different thing, you might want to constrain X somehow, and you might also want to constrain these parameters here.
Yes. Right.
Yeah.
Arguing against myself there a bit.
Yeah.
Yes.
I mean, also there's things, I guess you can do this with patterns, but there's also also things where you want to be able to make the, X appear more than once and have it be the same X.
Well, I just think that the processor for patterns is so you go through and you take a blank and you make it a unique variable and so 2 blanks, if that were a symbolic thing in solve, that would be dealt with as a symbol blank, and it would consider it to be the same parameter.
Yeah, which is wrong.
And solve, which is but so we need a special processor for patterns, which is going to have weird corner cases.
Well, I don't know how weird that be. Go ahead.
Here's maybe a question, because I think this relates to broader. Well, yeah. So it seems like one of the benefits of using blank would be that, at least I think, blank is hold first or something, right? So it's not, if you have X defined as 12 and you use X blank, that's not a problem, right?
That's correct.
Which is one of the really annoying things when using solve or minimize, whatever, that you got to be careful that, X isn't defined or something. So, but maybe we could have a wrapper that, that would work in minimize and solve and stuff too. That's also like blank, just hold first. And that basically just says, this is a little symbolic symbol. I'm going to call it X. But,
well, that's formal, basically.
Yes,
right?
but
well, I know there's formal X, but is there actually a head formal that you wrap around X?
No, but there maybe should be. And that's what we had that discussion about variables a few weeks ago, which we need to come back to. I don't know who is, that was an LCT discussion, as I recall.
Yeah.
Right? Okay, which we need to come back to. And by the way, when we come back to it, the idea of a formal wrapper, I think we discussed that in that meeting. Formal of X. I mean,
I don't think we discussed it in that specific meeting, but it's something we've discussed in the past.
Okay, well, but we need to come back to that topic, and when we come back to it, we need to talk about estimated distribution, estimated function. But I think the solution right now is this fourth argument to find fit. Fifth argument. Is it really the fifth argument?
Well, no, I think it's a rule syntax, if I recall correctly. I don't.
Okay, fine.
Remember, it's like what we did with fit, where we added a rule syntax to give.
Okay. Well, okay. Want. So let's come back to our. I mean, Christopher is claiming, by the way, that the X here is as irrelevant. In other words, that I don't really need, and do I in fact need it here? Do I need that second?
Oh, I mean, you need that X for sure, because you can't distinguish X from A.
Oh yeah, right.
How do you know what you're minimizing with
respect well, right. But so then I'm claiming it's not the same thing as the case of as this find fit case, because the find fit case, you are specifying the X. You can't get around that, but by exclusion, you know what the parameters are.
Well, suppose, okay, so here's a case, though. You might imagine we'd have a symbolic find fit.
Yeah.
Right, where you can fit to symbolic data.
Yes. Which we don't have right now.
Calls minimization, so it could call minimize in principle.
Which will be an interesting thing to explore. I mean, I'm not sure that that's a realistic thing, because the fact is that the chance that you have so little data that formula isn't just going to be absurd seems very low.
It would probably work. It would probably work in the linear case quite well, but that's pretty uncommon, right? So,
well, actually, another reason why it makes sense that find fit takes this argument is that, right? I mean, it returns a list of rules with these things, right? It makes sense that you ask.
Oh, sure.
Tell me,
Yes, if it's returning that list of rules. But that's why I'm saying we need an estimated function thing that doesn't return the list of rules and just returns the estimated function.
I just worry that there's going to be, I didn't like there's going to be, if I have a bug and I have some, I meant to just set X to 12, but I forgot. And now there's an unevaluated, or an undefined X in my expression. And how all of a sudden you're fitting it, like.
Well, that actually does happen, because and find fit localizes X, does the computation, then when it returns the thing, if X had a value, that gets substituted when it reevaluates.
Right. That's the opposite issue.
Can we go back to?
I was about to vote to go back to Tabular.
Right. Okay, transform missing, right? It's not transform
Yeah.
missing.
Yeah, it's missing. Sorry, typo. Me.
Okay. All right.
Okay, so basically,
here...
here's the idea. Then let's table this discussion about normal distribution MS to the. We should deal with this together with the rest, but.
I'm just trying to understand what this looks like. Column A, column B, we want to be a random variate.
Exactly.
But we need to say what kind of random variate. A random variate like that is kind of silly on its own.
This is why I bundled that with random. So it is the random sample if you.
I know, but
random
that's
choice.
Different from random elements.
Yeah. It's only the first part of random element or random variant, but yeah.
But that's really random choice, actually. That will be the correct name for that.
Yeah.
Is a random choice.
It is a random choice on the column every time, yes.
Well, except no, it isn't random choice, because random choice, it might be a discrete distribution. We might want random choice. So I think we do want to call it random element.
But there is a distinction between random choice and random sample. And maybe we want to have that here. Like you don't want.
Okay, but that's a different issue. I mean, this is, look, this is this thing here, right? For example.
Yeah.
Okay, so the issue is if you want parameters in the random variate, you could say something like this, and then you say random variate, list random variate, normal distribution, and I absolutely hate giving parameters there. I hate it. It's really horrible. But you're saying fit those parameters and then use it. As opposed to saying something like, I don't know.
1, 0, whatever, yeah.
No.
Wait, yeah, 1, 0 doesn't work. It's 0, 1, 1, 2, or 1, 3, yeah.
Right.
Don't do 1, 0. Yeah. But in this case, you're right. The syntax just with only random variate wouldn't make sense because you don't have a distribution.
Well, unless we assume a distribution, unless we assume a normal distribution.
Or unless we assume learned distribution.
Or no, not learned distribution. It's going to be like something like fine distribution, but that's very slow. I wouldn't go there. I would assume the normal distribution.
Pretty horrible, but yeah.
Yeah.
I mean, the truth is, most of the time, you could imagine you could just do that. I mean, if we're going to make it simple to use, this is going to be a common thing to want to do.
Yes, if the distribution is, has no other forms. Because, depending on the number of parameters in the distribution, you may have a different distribution.
Okay, reality check. When people do this in the real world, what distributions do they use?
Well, that could be normal, of course. That could be uniform. The question is whether you want to do uniform on the min-max or some other domain that you know for the data, because it might be that you know that your data was sampled from some interval and you want to put it in, and then, there are other distributions like gamma, for example, where we have, different number of parameters specify slightly different distribution, or maybe something, completely different.
So
I don't know.
I'm wondering whether we shouldn't just have, in terms of specifying, what do you do here? I mean, why not just have something that says, something like, well, this might be crazy, but something like this, where you can just say, where you can give something which is to be applied to the whole column, where you specify in an association what you want to do. That makes sense?
As a last resort type of thing.
Yeah.
Because you surely want these easy cases first, what you actually use.
Oh, yeah, sure. Yeah. And I take Gosha's point that uniform distribution isn't very well defined.
So what are the things that you should put in the association here?
I don't know. Potentially a function to apply to the whole column, but I'm not sure. Or just element function. So
but also you could delegate it to other processing functions we have. Have we talked column-wise here yet today?
We're trying to make transform columns work so that you can do that sort of thing just naturally.
And this was my initial point. Like at this point, it makes much easier to specify this with transform columns, and we should be working to make transform columns easy to use in these cases. Mm-hmm. Because you're really going to your custom thing. Yeah. So let's not create two functions that can do custom things.
Okay. Real world reality check. What do people mostly do? They mostly want to set it to constant values. That'll be the number one thing to do. Yes. Number two thing to do is probably mean value, maybe.
No, I think like random element. I think random element is usually the most principled thing to do.
Yeah. I mean, I put like the families that I put here are
I think common. Another common one is just to use the previous.
Yeah. And I have it there, like the next previews. Here I put one. Yeah,
or interpolate.
Exactly. So there's really four families here. Is constant, statistics, in terms of mean, median, random, and positional based. The one before, the one after. And this was yeah. I mean, the idea here is like, let's keep it very simple because this stuff will cover a lot of uses with a dedicated function. And missing fallback is, I think, the way to go to basically turn transform columns into the powerful missing imputer that you were trying to design with the association, Stephen.
How does it remind me how missing fallback works?
Missing fallback, I mean, you basically, in transform columns, you say missing fallback of #A, whatever you want to do, and that function will return A if it is non-missing and use your function if it is missing. So it's basically the only thing that you need to turn a normal function into a function that only works on missing elements.
But wait a second. But that thing cannot globally pick up a column, right? It can only pick up the.
I'm not gonna answer this because there's a meat for the next session in the discussion.
That's the next point of discussion.
Exactly. So let's table this consideration because it relies on.
Okay, but I'm not really keen on. I mean, I think this is really pretty cruddy, this syntax. Given that there's a perfectly reasonable. I mean, the problem is some of these require very supplied-like information about the local environment.
Mm-hmm. Yes.
Yep.
So, Stephen, what about let's move to the next part of the discussion.
All right. Okay.
And then maybe.
But I mean, maybe what we do is we do something like this. Well, there's nothing. Yeah, I mean, then this could then make use of whole column information. I mean, that function could be given whole column information here.
Yeah, this was the original design. That would have been a function that takes the whole column. But then you are starting to design something which is exactly like random column. Sorry, random column, like transform columns.
Column,
yeah.
So at that point, why not use transform columns?
Exactly.
Because transform columns doesn't get the whole column.
But that's what we're going to discuss now. According to your suggestion, Stephen.
It's your suggestion. So
let me add one little bit about anomalies because it's the kind of design directions here, and then we'll let Carlo and Rob speak about that also because I have to run away today. Sorry. So anomaly detection. Current functionality is the symbols that you see here. We have find anomalies that will return anomalous data, or with properties and non-anomalous or stuff like that. Delete anomalies, obvious thing. Anomaly detection is the one that trains the operator form of find anomalies. And then you have anomaly detection function, which is the result of anomaly detection, and anomaly detector, which is the optional property you can classify. So this is the state of things right now. Now, I said train. This stuff is basically a single method function because it relies on learned distribution, which has, in truth, multiple methods inside, like multi-normal, Gaussian mixture, and stuff like that. But basically, the whole system is based on learned distribution. and the concept of rare probability. So that if you have a distribution, then you can check a data point. It's like a p-value thing. If the probability of extracting that data point from the distribution is very, very low, that's an anomaly.
I remember.
Yeah. So this is the current system. Now we want to quote unquote generalize this thing to simpler things like missing, like the transform missing. So there are like few very, very common methods that don't require, they do require training in a sense, but it's more like fitting, that are like z-score, which, name open, which is based on
z-score,
standard deviations. Exactly.
Yes.
Interquartile range, median absolute deviation from the median.
But we have functions, right? Z-score, we have a function for computing the z-score.
Yes.
We do. I mean, again, this is for the sake of speed, that you do, operator form, find anomalies, z-score, piped on the tabular, and that you get the mask out.
How do you
no, it's called standardize, and then you have to
no
wait.
Z-score is relative to a distribution.
No, it's relative to the normal distribution fit on the data.
Right. What is the value of this thing? I mean, really what it would be is something more like
it's like absolute values of standardized of data less than 3, for example.
No, but standardized doesn't do that. Standardized actually messes with the data. I mean, if you say z-score of data, x, it should tell you the z-score of x relative to that data, right?
Oh, I see a point.
I don't know why we don't have that. We must have that somehow, somewhere. Maybe we call it confidence interval or something. What is that? What is that function? Statistics people, how do we get that?
What did you ask? What is it?
This thing here. The z-score with respect to this data fits to a Gaussian of this value. How do you get that?
Well, I thought that standardized with the centralize and then divide by the standard deviation.
No, it's not getting that. It's not doing. Oh, you mean that standardized gives you the z-scores for every variable, every element? But this, I'm asking for a particular element.
Is it?
No, I'm asking for a particular element relative to this distribution. What is its z-score?
Right.
How do I get that?
Right. So it's like mean of it's what is it? It's
it's
x minus mean of data divided by standard deviation of data.
Exactly.
Yes.
But yeah, maybe there could be a function for that.
I think that will be a useful function. Can we bring that to an ILD meeting, please?
Yeah, I'm taking note. Yes, I'm taking note.
So you want to have x minus mean of data divided by the standard deviation of data?
Pretty much, I think.
Okay.
Seems useful to me. Okay, in any case, what are you showing here?
Yeah, I mean, that is basically a way to extend the design of find anomalies. So if you open find anomalies new, that is a link.
For missing data, we already know it in the tabular. For outliers or anomalies, we don't know it. So the first thing is to find it. And how do you define it? So that's what this one gives. And it can give the same bit vector back as we have for missings and stuff. And we now add it to select.
I'm sorry, I'm confused here. What are we doing?
Open the documentation for find anomalies new. There's a link there. You can just click on that link. No, you will ignore my link.
I'm going to have to go in like 15 minutes or so. So I think it's important that we get to this other stuff.
Okay. I mean, we can cycle back to this if you want. So these are the current find anomalies.
Let's put this on the agenda for Monday and look at column wise now.
Okay.
So that
fine by me.
Okay.
Last time, remember, we talked about transform column semantics, and we came up with one idea was transform whole columns, a completely separate command that had evaluation semantics for reduced tabular. Another idea, which you'd suggested looking at, was this. You called it column-wise evaluated. Colin and I talked, and we thought, well, maybe why don't we just make column-wise inside the function just do that? So it basically does a single evaluation and it works. And so that's what he wrote some top level
lexically.
Lexically.
So it does
exactly.
2 things. It changes the meaning of the slots within it, and it also like it works like once. Like basically it replaces the value of the mean, so it doesn't do it n times.
Right.
So that solves that n squared problem.
It's lexical, it's simple, it works also with normal evaluation.
And how does it relate to element-wise?
So, well, this is by default element-wise, so we don't really
means
need...
No, I understand.
A problem you didn't like with transform whole columns is, say, instead of instead of the minus there, we say had a greater than or something. You had to use an element-wise in the tabular whole columns, and this avoids that. So it's sort of a different. It's the opposite direction of element-wise in some sense.
Now, I know, but I'm asking, given that it is similar in functionality to element-wise, is its semantics the same? Because element-wise is a headdress.
No, this is not. This is a
no.
I know this is not a headdress. I know. So I'm complaining about the fact that it sounds similar to element-wise, but element-wise is a headdress.
Yes, we could have a completely different name for it. By columns or something else like that. I mean, maybe column-wise may not be the right name.
Or maybe element-wise isn't the right name. I don't know, but one of the two. It can't have one of them.
Yeah.
One of the wise
things
be a headdress.
Agreed.
Yeah, absolutely. I understand your objection, and that's a good objection.
Okay, and then we thought that there are some situations where column-wise doesn't return a scalar, and so you need to do something which is like the opposite of threaded to redistribute that. So we propose another symbol we like tentatively called weave.
Oh my gosh. The boat is sinking. We got thread and we've got weave, and then we'll have knit, I suppose.
I mean, weave, it's kind of a pun. We wait for a better symbol. But the idea is that weave is basically just part with
I don't understand. If column-wise returns something which is a list, why not just thread it?
Because look at the example just below. We knew you were going to ask that. There are some situations where you can't, like, it's fragile to rely on the fact that it's a list. It might not be the right length. It might be the right length for completely random reasons.
So the example that's problematic like that are part semantics. So if you have a list and you do, part.
Look, the only way I can see this working is to have two different functions here. One that expects to get a scalar and one that expects to get a list that it will be threaded.
Yeah, that's what I actually suggested as a possibility. So
as a matter of fact, you can't use weave without really using column-wise.
Right. No. It's so two separate heads. We need to come up with some names, but I think in principle this is actually it's quite workable.
I think will be quite nice to use.
Yeah. So we just have to figure out the names. But I think this is nicer. Honestly, I think this is nicer than the transform whole column solution.
I do too.
Okay.
I think it's more flexible, and I think that I don't know what happens if you do weird stuff like nesting. Okay, so I
think nesting will be an error.
No, nesting of just column-wise is probably just it's idempotent. Is
that a possibility of doing something like that?
I think it's more like columnar block or something like that, because it's like it switches to columnar mode.
Yeah,
temporarily.
But I like the list, and the value. Those are good. And we'll.
Hold on. Let's think. I think that's very weird. Obscure seeming. Well, I wonder if we could get away with using column-wise list, column-wise value, on the grounds that then it's a different thing from from just a
Oh,
pure.
yeah, then it does feel different than element-wise a bit.
Well, let's just see. Column-wise value. How about, maybe this is wrong as well. Is that the wrong meaning as well? I'm not sure. Let's see. Yeah, because
it's not crazy because it changes the way the function is applied in some sense. So
I see. Yes, right. It's like reverse applied.
Yeah.
It's really, if you want to put it that way, it's really transposed applied.
Is it?
No, not really, because it's okay. So reverse applied is a headdress, right?
The problem I have with applied is that we're really talking about in either case, we're just talking about a single argument, which is the association.
No, it's not a function. It's really a block.
What do you mean by being a block? It's not a block. There's
it's
hash A, which is a row element, and there's the other hash A inside that thing that is supposed to be a column element.
Yeah, but it's not a function. Like a function is a first class citizen in language, and it's not a function, right?
Yeah.
And the other thing is that if the outside function has a first and second argument, you don't want to repeat the first argument just for that.
Nice.
That's hopeless.
Yeah. I think the nicer in this list are column-wise list and column-wise value.
Yeah.
Yeah.
But let's see, column-wise list.
I like the fact that list and value in the name kind of imply that this thing evaluates only once.
Yeah, a little bit.
Gets replaced with the value.
Yeah.
But I mean, the typical thing you'd see is X arrow column-wise value mean of hash. Well, it could even be hash X.
Yeah, that
could be
replaces
hash
that.
X.
Yeah.
And typically, a common thing is to do, minus hash X from
Or,
that.
another cool thing about this is that you can do missing fallback of hash A, and then you get the thing we were talking about.
Mm-hmm.
Hold on. I don't understand here.
No, you put the hash A outside the column-wise value.
No, yeah, right.
Right, because that you want element-wise. Exactly.
Yeah.
Yeah.
That's not bad.
No, I think that allows you could change the minus to a less or greater to compare whether it's, and it works the same way. You don't have to do any special things with element-wise.
With missing fallback.
Yeah.
Right, but then column-wise value would apply to all variables inside here, right?
That's right.
Does that look weird if we have, for example, a function? Oh, it looks fine, right? There's nothing wrong with this. That's just fine.
Yeah, so it uses the same function replacement. It just does a replacement before evaluating the function to do that same function replacement, but just on those parts.
Yeah, I mean, that model, I suspect there are other uses for that model in other parts of the system.
One thing that is a little bit confusing, I think, about his names is that if you use column-wise value and you have something like accumulate that returns a list, then you get a list in the values. If you use column-wise list, then you get each value. So maybe they're, you see what I'm saying? Like
so that's my question. So what happens when somebody says column-wise value quantiles of A?
Then they're going to get that thing of 3 elements, and that's what they're asking for.
There's an example above, just above the cut in the screen, where you get 2, 9, 14, 18, 22, 28, 33.
Okay, so that means that's you kind of treat it as a value, and otherwise you kind of treat it differently.
Right.
Which is a bit confusing in the names, though. So
yeah.
Well, if you give a list and it doesn't have the right length, then that's going to be an error.
Yeah. But I wonder if it should be something like column-wise whole and column-wise part, something like that, rather than value and list.
Sorry, I spaced for a second. Could you?
Well, so the question is like the list. If you pass to column-wise value something that returns a list, then it will plug in a list as the value, and so that's kind of confusing about the name.
I'm sorry.
Like
say it one more time.
First example on your screen, on top, with the one which is cut off. That's a case of column-wise. The first one is column-wise value, and the second one is column-wise list. And the column-wise value puts lists, and column-wise list puts value.
Column-wise value there.
Yeah. Would do that.
Accumulate, right? Because it's making just a value.
Yeah.
Okay. And
that would be column-wise list. So the one that turns list is column-wise value.
You see the confusion that the value
return a list. It locally, this value here, I mean, for every element-wise element, yeah, I mean, this one is doing it element-wise here. The second one is threading the values back in, right?
Yep. Right. Exactly.
Could it be column-wise and column-wise thread?
I don't like column-wise on its own.
Okay. Yeah. Well, column-wise value and column-wise thread.
No, I don't think so, because, well,
it's not a list.
Yeah, you're right.
Yeah, thread is not terrible, because then we could have things like, the errors you'd get if it had the wrong length would be like thread errors.
Well, so what will it look like? We could say, let's imagine that we said...
No, but that's wrong. The function goes outside column-wise thread.
I understand. So minus column-wise value of mean of hash A, or total of hash, whatever it is. That's not terrible.
Yeah. No. This seems reasonable to me.
All right.
Okay, then there is another proposal which is kind of orthogonal, like we could have both, which is what if we use the extended key syntax to have some kind of reserved names for things like whole tabular row number, like ambient values that do not get displayed, but they're always there.
I don't know.
Because the cool thing about that
I don't know why that isn't supplied. That seems very much, that's basically supplied territory.
It is a bit
the cool thing about that is that you can use hash, whole tabular. Unless there is collision, then you have to prefix it. And so you don't have to invent weird new keys. You use the extended key mechanism.
I can't think about this right now.
Okay.
I really think this seems like supplied, but I might be wrong, which is bringing in ambient information into the middle of a function somewhere.
Yeah, but this we can do it basically for free. Like for
Well,
for every call to transform column or reduce tabular and so on.
yeah, but I mean, so okay.
It's a bit like making, so supplied is a thing, you do supplied of blah, blah, blah. I mean, maybe we could have supplied work specially for transform columns that would bring these things in. Maybe we can look into that in the meantime.
The good thing about having this kind of extended key is that you can get all of them without asking them and just have them be ambient. And they don't show up, that you don't have to say supplied. They're just there all the time.
Yeah, I need to run.
Okay.
Yeah.
See you guys soon.
Okay, well, good. I think we got somewhere on this finally. So that's good.
Yeah.
Okay.
Thanks.
Good stuff.
All right.